All right. Hello. Good morning. So, as I mentioned as I mentioned on this Discord channel that we're using. By the way, happy to invite anyone into that channel if anyone likes discussing these patterns and state management in general. Let me know. But yeah, I made this statement that actually, let's see. About 4 years ago, Christian Alfon. I have this thing. Christian Alfoni React States. Yeah, so I made this video about 4 years ago about how to express explicit states, and it actually got a decent number of views. So it was something I felt like I was conveying something that was useful, because we've been at this point we'd heard a lot about X state, but we heard about it from this declarative abstraction and building these machines and more describing these machines as opposed to implementing it with code. And this thing here was just using React primitives to implement the same concept. And when I learned about this, I thought that was a very isolated concept. But it actually had waves into everything state management. So what the whole thing about strict null checking, how do you actually pass state down your components with a strong contract when you have state that changes, that's dynamic. You don't have the guarantees that when you use a hook, that state might actually not be available because the component doesn't know about it only has a contract with its parent component. And all of this stuff. So as I stated on the Discord channel, we kind of colored all the boxes of what it actually means to do state management in the context of using explicit states and state machines. But I'm still holding true the fact that if you're able to describe your app as a static state tree, you'll have a much easier time implementing and keeping a strong mental model of that. When you start using explicit states and these state machines, you will have, at least theoretically, or you will have. So how should I put this? It's not about using state machines or not. It's about the app, right? So for example, so this to-do app doesn't need a state machine, right? It's just what I describe here. It just has them new to do, title edit, to do, title to do's, and it's fine to use hooks here, right? I guess that's the best way to say it. It's fine to use hooks here because there's no dynamic nature of this state. But what if you could only access this state when you're an authenticated user? And some component would suddenly use a hook to go and grab this state branch, but it's actually behind the authenticated state, which means that you would start doing things in the component where the user isn't authenticated, or you would try to grab the branch, but it's null because you haven't been authenticated yet, right? So that's what I mean. And then you can ask, what if, should you strive to keep your state model, what should we call it? State model, your state tree static, even though it has some dynamic nature to it? For example, being authenticated or not could be represented as having a user or not. But But at the same time, if you're using TypeScript and there is like that dynamic nature of your app will leak through into your state tree no matter. So again, using the user as an example, if the user might be there or might not be there, you will have typing that represents a dynamic nature of your state tree. So if you have a hook called use user, that has to return a user or null because it's actually using the user from the state tree, and that user might be there or might not be there. But if you don't properly like create a state tree where the actual state and functionality that's available to you when there is an actual user there, and then you provide that to the components through props with a strong contract, that's like, you won't go wrong with that. Yeah, it's very interesting. It would be really, really fun to do like an exercise where people working on apps using this single state tree model, it being classes or whatever it is, it doesn't matter. But they will kind of come to the table with just an object description like this for one or multiple versions of that tree and like just talk about it. But anyways, we're actually going to code today. So we're in this groceries thing, and we're actually going to do the pattern I talked about, and we're going to create a reference cache. That's what we're going to call it. And then we can call that constructor or create. We're not going to call it view. We're going to call it state. State. So we're creating some, or create state. Oh, let's call it create. I don't want that. So this is D, and then we have S that represents the state. So the point here is that, we're actually gonna do a little check on this. What does actually Firebase do? Let's see, I'm connected to production, so I'm gonna mess up our grocery list, but I want to see what happens to the data. I want to see, or maybe I can ask, just ask ChatGPT. So I am using Firebase and a snapshot subscription to a collection. Whenever I add something to the collection, does the existing items in the snapshot value change their reference? Or does Firebase, there's a term for this, like ensuring consistency, reference consistency or something? Or does Firebase ensure consistency in object references as long as the data did not change? Yeah, exactly. Okay, Firebase, both Firestore and real-time database, will send you a completely new snapshot every time there is any change in your collection. That means even if a document's data hasn't changed, its object reference in the snapshot is typically a new instance. So if you add a new item to your collection, the snapshot you receive will include new instances for all documents, even those that haven't changed. Firebase does not guarantee that the object references will remain consistent between updates. Yeah, that's interesting. Like that's like a problem. I think that's really bad. Because it has like, but again, like then we don't need to do this thing. The The only reason for do this create reference cache is if it was true that whenever I added something to the grocery list, the existing grocery documents from Firebase would keep their reference, right? Because we're going to wrap those documents with our own state management, which is a new object in and of itself. And we wouldn't want to create that wrapper if the underlying document hasn't changed. So we're going to remove that. So I guess maybe the only time you can really control this is if you, this is very interesting to me, because this makes it quite impossible to optimize. This makes it quite impossible to optimize lists. Okay, we're gonna get stuck on this one. Because the whole point of a list is that you map over some data. Function my list component. I wonder how. So you do, yeah, whatever. Let's just do, so you have some groceries and you map over those. And then you have a grocery and then you render like a grocery, right? And that grocery isn't very complex, but the whole point is to have something predictable. And what you would do here if you had actual immutable data and you didn't have, like, everything was immutable, it was very React-ish, is that you would do id grocery.id. Well, not necessarily. Let's just pass grocery. So, and again, it's just React, it's immutable. So the whole point of this is that now you would be able to make grocery a memo component, because the only time grocery actually changes its reference is if the grocery changes. But that's not true for data fetching. As we just saw, when it's coming from Firebase, if you're using React query, like, it always changes. So if something is manipulated in groceries, it's being any of the items, it being adding or removing items, it doesn't matter. If groceries are manipulated, it will change the reference of all items, meaning it will render or reconcile every item in the list. And normally that's not a problem at all. But it makes me think about how you, yeah, so I guess like for, yeah, so I guess, yeah, interesting. So, okay, this is very interesting, because in subscribe to data, there is something called, where do we have the, yeah, so I'm using on collection snapshot, but there is a different thing called Firebase on collection changes. Yeah, I guess that's the difference. Because when you have the revalidate strategy, which is like React query, it's kind of like on collection snapshot. Whatever changes, it brings down a whole new snapshot of that collection. But here we have something called on collection changes, and then, oh yeah, sorry, changes. And then you can iterate the changes. And that change has a type, I think. Yeah. So has it been added, modified, or removed? So what we can do here is that we rather listen to changes, and then we manipulate the array to reflect that change, right? And that will cause a mutation, and it will optimally, okay, that's very interesting. That is very interesting. So on collection snapshot is revalidate. It's just a subscription-based revalidate. While on collection changes, that's like the actual changes made to the list. So you can like optimally mutate the list to reflect that change. And then you keep all the references and everything. So when it comes to the documentation here, data fetching. So when you do manual mutation, that's when you grab the backend data from the backend and you put it into your state. And then whenever you like change anything, you just change it directly on your to-dos in this case, right? So you're mutating the to-dos array and keeping it optimal for reconciliation and observation. And then you just sync that change back to the database, where you would of course have to handle if that fails, you would have to revert the change in the client. But the bonus of this approach, even looking at Firebase, is that it is exceptionally snappy. Like every single interaction happens immediately. It truly feels like you're working locally. And this is a big deal for a lot of apps. Like having these tiny like latency on an interaction or loading states, it really completely changes how you experience the product. So you might say that this isn't like safe or guaranteed or whatever, but it's an excellent user experience. And if you're able to control this, well, it's going to be the best possible experience in my own experience building apps. And then we have revalidate on mutations. So this is actually like React query, but also snapshot subscriptions on Firebase, as we just learned. It's basically replacing all the to-dos every time, regardless of what happened. And then we have automatic sync. Yeah, so I'm going to write something about that. So the conclusion here is like, if you have, so we shouldn't think about data fetching as, it's actually just two things. Like one thing is the data fetching solution, but another thing is to think about it as, how does your data update in the client? Like, is the data replaced for every update? Is it revalidating for every update? Or do you have a subscription to specific changes to granularly update the data, keeping it in sync? And the latter is much better for this approach, or for any approach. Like, it doesn't matter if you have like traditional mutable React or you're using a mutable state tree. It doesn't matter. It's just, that is how you think about optimizing a list representing data. It's normally you can do revalidation of all the data, because even though the list reconciles completely, like it won't update the DOM, right? That's what the reconciler handles. But if it is like a complex list that updates a lot, you should rather subscribe to the data changes as opposed to the data itself. And then you granularly update exactly where the change has been made. And if you have a mutable state tree, that's going to be super optimal, because just the item component itself that changed, or the item component handling a specific data item, that will reconcile. While with traditional React immutability, it will also reconcile the list itself. Yeah, but no, that's not a biggie. But it's very interesting. I haven't put it like that before in my head. So I'm gonna rework this documentation again. But okay, so in this app, we don't really, let's open it. So family scrum. So definitely the shopping list doesn't hurt, not the checklist. Plan next week. That now we're starting to see something that might benefit from having on change subscription instead of on snapshot, because there is quite a bit of data here, and like the change is very like specific. It's like deep, so we could explore that when we get there. But let's do like a very traditional groceries list finally. So what we're gonna do first, I'm gonna put all the data stuff into its own thing. So this would be family scrum data. Let's shove that in here so we clean up a little bit. And then we're gonna put, let's see. Oh yeah, sorry. Not that one, but this whole subscribe to data. This is actually gonna be put into data. And then instead of, we're gonna export const create data. And we're gonna pass it APIs. And then it needs a session. And I guess that's session authenticated. Cool. And then we have Firebase coming from APIs. Yeah, and then we just miss a bunch of imports. Let's copy this over. Why don't I need all of these? That's weird. Weak data. So this will be API session. Where is the, oh, there I had a mistake there. But why do I have all these imports? Let's see, and weak data isn't there? Oh, I think I have, oh, where the fuck did my types go? Where the, oh, seem to have misplaced my types. That's weird. Okay, data. So, and we're gonna export data state. Sorry, let's rename that data state. And we have weak data. Okay, now it's happy. So when we create our data, this is not something we're actually going to expose to the components. We're going to expose our own interface to the components to interact with the data. But another thing I'm going to do here, I'm not going to even call it Firebase. I'm going to call it like persistence or something. And then I'm going to put a lot of this stuff. Like we're not going to have the collections or anything like that. We're actually going to create the persistence, passing in the family ID, and then we're gonna get like very like domain specific, a very domain specific interface out of that. Like it's gonna be persistence dot groceries dot subscribe, or subscribe changes, or add or remove, stuff like that. So we're leaking a ton of Firebase stuff into our code, and I don't like it. But we can do that some other time. But what it does is that it just subscribes to, by the way, I'm also gonna make sure that we do, this is also a thing, previous week. Yeah, let's see, we're gonna move this stuff. Let's see, 2 seconds. I'm gonna clean this up a little bit. So I don't want all of this stuff to be right here. I want this to be, I guess we're gonna call it create weak data. And then we're gonna put that into a function underneath here. Create weak data. And weak ID, I think it's a string. Yeah, and we're also gonna do these two, we're gonna shove them in here. Oh, it returns void. Oh, look at me. There we go. So we're just grabbing a bunch of constants, we're grabbing the weeks, and then we create the data. Because I think the way I think about this constructor is that, okay, first we go and grab all the properties, right? Then we create the actual reactive state, and then we go and set up any side effects that we have. And then we return that data. Oh, we can move this up as well. And then we return the actual state. And then we have the methods. Cool. Let's remove some of these. So I think that's the cleanest. So when you're kind of reading one of these constructor function, I'm just calling constructors, you kind of see, okay, what like values are we dealing with? What state are we defining? And what like effects are we firing up? Here are some subscriptions, and then what methods do we have? So another thing that's really nice about this is that when you read this code as a new developer, you want to know about what this thing does, right? But you don't care about the implementation details. So currently, I don't really have much functionality here, but you can imagine instead of implementing each method on the object here, I just reference a function below the return. But that means you can just click it and then you go to it to see the actual implementation details, but it gives you such a nice overview of what this thing actually does. As opposed to in the class, you're hesitant about it, even just organizing the methods. One thing is your methods has the actual implementation, so you have to scroll through a lot of stuff and you kind of lose track of what methods are actually implemented in this class. But when you have this structure of defining the actual instance up here with references to the methods, you just have this very precise description of what this thing is. And then you can just command click through it. So I can like even take unsubscribe here and I can move that into its own thing. And it's so easy to refactor this. So I do unsubscribe and then we say function unsubscribe. And there we have unsubscribe. I don't have to change anything because we're in the same closure. So it points to the same stuff. That's the beauty of this. It's like super, super simple to clean it up. And now I can just click unsubscribe and then I go to the implementation of unsubscribe. And it doesn't even take me out. Like it's such a nice, like understanding the code experience. Because it doesn't even take me out of where I am looking at the code. I just go to, okay, that's the implementation. And then I can continue like analyzing what this thing actually is. Cool. And I could even like move these into their own functions, right? To clean it up even more. But anyways, so we created our data. Create groceries. What's, oh, is it just, Oh, 3 arguments. What does it want? API's family scrum. Oh yeah, sorry. So we should pass. Oh, that's interesting. Yeah, we have to make these getters. Get groceries. Oh, this one's interesting. Because in this case, I want to make groceries a getter. Okay, so I think this is very interesting. So we have family. Oh yeah, no, it wasn't very interesting. I have family scrum here. Oh, does it take? Oh, sorry. So this should be. I just had a complete wrong. Why is this complaining? Oh, interesting. Oh, look at this. Yeah, this is interesting. Yeah, this shouldn't be views. This should be view. And this needs to be view. This is just how getters work. You have to have what's it called? Explicit return types. And then we have view stack. We can move. Okay, maybe we can move this down here like this. So we also want to pass in family scrum here because this is related to the pattern of always passing parent state down to nested state. So in create dashboard. Oh, this is getting old. By the way, I'm going to change APIs to context as well because it's like you're passing a context to your state tree. And that context can hold many different things. Any like effects like persistence or any like environment variables, it doesn't matter. It's just a context your state tree operates in. It's like it's just a term for encapsulating all the environment specifics of running your app. So that will be family scrum, and that will be family scrum state. Cool. So that's fine. Yes, I could have moved these into their own functions, but I'm not going to do that. And then we have the view stack. Yeah, we have everything we need here. And then in groceries, we're not gonna do this. We're gonna do this. Cool. Create grocery item. This is not. This is gonna be shop. And when we shop something, we're actually just gonna remove it. So APIs Firebase. Yeah, this is kind of, you know what? I think we're gonna refactor Firebase first because this is gonna affect a lot of our code because it's so low level now. So I think we're gonna do that refactor in this stream instead. And then we'll see how much nicer it's gonna look. Oh, let's remove that. Okay, so let's and it's maybe we should write some. There was 2 things I'm gonna write about. I'm gonna write about, let's see, let me bring up Bonsify here. Bonsify. So we're gonna, let's see, pull down And then we're gonna, let's see, rather write about how, oh, have you seen this? Wait, is this an actual thing? No, it was just a. It's interesting. Okay, whatever. Rather write a. Oh, maybe it isn't like an internal thing. So it's like slash to do or comment to do or something. Write about data optimization actually being about revalidate versus granular updates. That's really what it's about. So if you have revalidate, it doesn't matter it doesn't matter if you're revalidating manually, you're revalidating using something like use query or React query, or you're revalidating using a subscription. That doesn't matter. You're revalidating the whole thing, changing out all the references regardless of what actually changed in the data, versus doing granular changes or granular updates. And granular updates is the thing that would need that optimization, given that you're deriving your data into some state wrapper to protect that data, if you care about that optimization. So that's one thing. And then I want to write about I think I'm going to create a new section. So new section on context. Oh, why didn't you? What? Oh, interesting. So it doesn't take the first word? Huh. Create a new section on passing a context. Okay. Let's get to the refactor. So I have, I'm calling it APIs here. Let's immediately change it into context. And then you could add different contexts, right? You could have a test context. You could have like a server side context or native context. Like, it doesn't matter. But I'm just going to call it context here. And then let's change this, rename into context. And this would be rename context. So we're going to allow it to just be like this, but we're going to call it persistence instead. So we're actually, so if I actually had multiple contexts here, I would define an explicit type so that I could implement that context in different ways. But since we're only having one here, we can just change this. So let's rename that to persistence. And then we're gonna, rename, create Firebase persistence. Oh, interesting. And then we have Firebase here. Where are create Firebase persistence? Okay. So let's look through this. So what I want to do is okay. Okay, so we're actually not going to return an object here. We're going to return a constructor so that, because the whole point is that all you interact with is based on your family ID. So we're gonna return something that constructs, yeah, sorry. So how are we gonna do this? Because some of it is not specific to, so for example, signing in and on-auth changed, it's really these collections. Oh, now we're getting into it. Like we have this issue now where we're refactoring, because now we encapsulated it in Firebase. So now authentication and everything makes sense, right? But because it's part of Firebase, but from like a consumption standpoint, it doesn't make sense. So what I think we actually need to do here is to do create context. And it just happens to be that Firebase is handling my authentication and my persistence, but that might not be true. So we're going to have authentication here as well. Create Firebase authentication. And this will be return type, return type of create context. And what we're going to do is that we're going to fire up Firebase as part of creating our context. And then we're going to pass in Firebase to persistence and authentication so that we can handle those things. So we're going to do just initialize app out here. Let's see. Let's call it, okay, let's just call it app. And we're going to pass that in here. We're going to pass it in here. And this is going to be a Firebase app. So let's create, not Firebase, but let's create authentication TS. Export function create Firebase authentication. App is Firebase. And the whole reason we do this is because when you're writing code for your app, it's like domain specific code, right? It's in the context of what your app is doing. And Firebase isn't your app. It's just a lower level implementation. And you don't want to leak those concepts into your code. There's enough code there to describe what your actual app is doing within its domain. And when you have like half of your code is like Firebase specific code, then it's very hard to reason about. And there's so much irrelevant fluff there. So if you actually want to do something related to Firebase, you jump into your context code for Firebase, for the environment where Firebase is actually running. Let's see. And then we have, let's just move whatever's related to, so use device. Yeah, we can, oh, this is auth. Okay, so we're gonna do that as well. Yeah, I think this is what we need from authentication. And then get auth, and then use device language. And then we're gonna return the actual functionality of authentication. So that will be on auth changed, and let's see. Is this coming from Firebase auth? Oh, interesting. Sign in with pop-up. Where's that coming from? Oh, that's also from Firebase. Cool. So I think this is really our authentication. Oh, I'm feeling that I'm getting back into some early days mental models. It makes me happy. Let's see. So that is that. And then this is actually going to be, this is going to get the Firebase app. Initialize Firestore, get Firestore, storage. Yes. So the thing we need to do now is think about how we want to do this. So this is actually going to be like a constructor, or it's actually going to return a constructor. Because as I said, we want to wrap all this functionality around the actual family. Upload, get, yeah. So I think we're just going to do that. Because we still need to initialize all this stuff. Yeah, so what I could have done here is like move this stuff outside, but I like it's tied to persistence, so we're not going to do that. But what we're going to do instead is return a function that takes a family ID. And then we actually create everything. And then we're going to do a lot of changes here. Cool. The only thing that's kind of I don't like about this is that we're going to actually inside our family scrum, this is where we're going to actually create, because this is now we have an authenticated session with the family ID. So this is where we're going to create the persistence. But now we kind of have this context that kind of handles like authentication and has like the factory for creating persistence. But after that, we have to pass that persistence specifically. But that, I don't think it matters, because we're just going to, maybe we can even actually create that persistence inside create data, because we want to hide all data manipulation behind well, I'm not sure. We'll see what happens. No matter, this is where we're going to actually create our persistence wrapped around family ID. So let's take a look at how we're going to do this. So we're not going to call it collections. I think what we're rather going to do is, so let's just take one thing. So this is users. And users is going to have, so this is actually the getter. Maybe we should call it fetch. Something like that. And then we have a similar on collection snapshot, on doc snapshot. Yeah, and because here we're passing the collection ref, and this is what I want to normalize this so that every domain has its own on changes, on snapshot, or on change. Like it doesn't even mention snapshots. It's just because here we pass the collection ref, so it's very like, yeah. So what I was thinking is that we can actually create a type for this. Let's just implement one of them first. So we're gonna have fetch, we're gonna have subscribe, and we're gonna have on changes. Or maybe we should do on change, on changes. And then we're gonna have, what was it? Oh, this is interesting. So we have one for on users change, on users changes, on user change. I'm not sure if I'm actually using that. We'll figure it out. And then we have create ID. Create ID. We have get doc, get docs, set doc. Okay. Get all. Or get users. Get user. Let's see how I want to do this. I'm just exploring now, so we might change this. And then, yeah, get user, get users, set user, delete user, update user. So we have get user, set user, update user. And then we kind of have this transaction, and that means we're basically updating a user with a callback. That's the only difference, really. So I wonder if we don't even need that. We can just give a callback to make the update, and that's a transaction. And then we have upload, upload and get image URL, but these are general things. So upload, get image URL. That's fine that we put that there. Oh, but I think image ref. Yeah, that's fine. Okay, so let's move those up first. I'm gonna have you here. And then we have users. So let's see, create ID would be, where do we have create ID? So that would be, I think actually we can create like, yeah, no, we can't really do that. Is it possible to do like a generic thing here? Users get, set, update, get all. On how would we generically describe on all changed? But that's not true. Subscribe all. Like we have 3 versions of this. We can subscribe to changes to all users, but we're not subscribing to changes to all users. We're subscribing to so we can do subscribe. Subscribe changes. And then it's the last one, like subscribe like a single thing. But I don't want to use the term user. What we could do is we can make subscribe take an optional ID. Okay, let's try that. So you can subscribe, which subscribes to all, or you can pass an ID, which subscribes to a specific user, or you can subscribe changes. And I'm not sure if you can on collection changes on doc snapshot. There's nothing like on doc changes. No. Okay. So let's try this. Create ID. Where's create ID? There we have it. So by doing this, we should be able to create a factory. I'm just gonna, that takes a collection and then you just get this interface, which is gonna be nice. So this would be, yeah, let's go and grab all the collections first. So that's in data. We have all these collections. Let's call it app. Oh, sorry. Where did we get the collections from? I had collections. Oh, wait a minute. Was this from users? Was it? What was the collection here? Can I see the diff, please? Hello. Oh. Collection users. No, it's user data. Where the hell did that go? That's interesting. Okay, let's get back to our. So we need a users collection. Oh, sorry. Oh, collection is an actual. Oh, interesting. Okay, let's see if we can get this rolling. So we have users collection, that one's fine, but then we need get family docref. Yeah, now we don't need to do that. We can change this into rename family docref. We can remove this, simplify that, and then we have family ID. Okay, nice. Now we're getting it. Wait. Oh. Wait a minute. What's this? Yeah, sorry. So this needs to be replaced. This needs to be, sorry, I'm just messing it up here. So let's go and find groceries. So this is groceries. But we don't have to call it. We just use family docref. There we go. This is how we're gonna do it. And then we have the to-dos. So all this data is like behind the actual family, which is why we're doing this. And then this one is weeks. Weeks collection. We don't need this anymore. Oh yeah. That was weeks, and then we have week to-dos. Do we have that one here as well? No, let's add it. Week to-dos collection. Oh yeah, so this one actually is yeah, we have to move. Yeah, how are we going to deal with the weeks? Because they are dynamic. I think we're going to do the same, but we need to be able to. Okay. let's change this. So week to-dos is something else. So now we have users, and we're gonna have how are we gonna do this? So we're gonna do something similar. So family is one thing we're wrapping functionality around, but we also need to wrap functionality around a specific week. So the question is just, what should we call it? So this is week to-dos, right? Yeah. So it's not like get week to-dos, because then it sounds like you're actually getting the week to-dos, and you're not doing that. What you're doing is, oh, you know what? I think we just have to change. Yeah, sorry. No, we're going to do it a little bit differently. So we're going to do this. Family ID, and then we're going to do get week to-dos collection like this. Oh, sorry, family docref. And then we're going to do week ID string. And then we're still going to have the same, we're going to have week to-dos, but you have to pass in the week ID, right? That's the difference. So this would be users collection ID. Okay, we're getting there. We're getting there. And then we have dinners collection. And then we have families, but we already have families, right? Oh, that's users collection. Okay, this is dinners collection. Dinners collection, and then we have families collection. Cool. Let's see. Yeah, and that's also something we can put up here because it's not bound to a family ID. Nice. Okay, so we have all our collections, and we have this factory for getting the previous week, the current week, and the next. Good evening, Adam. And let's see, upload is fine, get image, and then we have users. Now let's insert the rest of the functionality for these things. And then we're going to make a factory out of this, and then it's going to be all good. So let's remove collections. Yeah, so let's, now we can move each of these. So this is on collection changes. So that will be subscribe changes. And this would be collection user data. And then, wait a minute. No, wait, sorry, users collection, sorry. And then we're gonna move this up here. And this would be user DTO. Nice. And then we can remove that. And then we have on collection snapshot, where we're gonna take this one. And then this will be users collection. And again, we're gonna do subscribe user DTO. So what we talked about is allowing you to pass in an ID. So Yeah, it's still early here. Well, it's not super early, but yeah. I kind of want to create another one. Subscribe. Okay, we're going to call this subscribe all. Yeah, well, I'm just going to do that. And then I know what it is. I don't want to spend too much time on this. So subscribe is for a single user. Subscribe all is for all the users. Subscribe changes is changes to any user, right? That makes sense. So let's move that one up. So we actually need the ID here. Oops. String, and then users collection. Yeah, and then we have the actual callback. Where are we? This is going to be user DTO. Nice. And we can remove all of this. Then we have get doc, which will be get, which takes an ID. Oh, and it's async. This is users collection. And then we're going to move get docs. And this is what I find fun. Like, you can think about like backend developers, like they're serving a client, right? You can think about it as a product, and the interface is the value. Like how efficiently and enjoyably can consumers of the API get their data, right? It's like it's product development. I get into a product development mindset when I think about APIs. And as a backend developer, that is a REST or GraphQL interface, right? And that's how I love to think about this as well. I am creating a product for UI engineers. And that product is the state management interface. And as simpler and more domain specific that is, the better that product is for the UI engineers, and the more enjoyable it is to work with. But state management is more complex than binding backend data to the UI. Like there's all kinds of shit you have to deal with, which is the fun part if you have good primitives. Oh, we're not. Oh, just wait, Adam. Just wait. I have a plan. I'm gonna blow. Oh, this is so fun. I'm gonna blow your mind. Stay tuned. Oh, I'm so excited. Users collection. And then we have setdoc. So that would be. Oh, wasn't that what I just did? Wait. Which one was that? What did I do? Oh, get doc. Sorry. This should have been on get all. Wait, but I have get all. What the hell? Oh, this was some old code. Sorry. This is how it should look. Sorry. Just wait. Just wait. And this is setdoc. Oh yeah, and this one's interesting because setdoc is. Oh, did I remove it? Oh, come on. It has a bit. Yeah, t extends ID. Okay. Well, I guess, no, wait, this is an actual user now, so that's fine. Cool. No, what I like a huge ass. I'm gonna make that conclusion after I'm done here. But let's see. So this was update users collection. User update data user DTO. I guess it's like partial user. But it's not partial user either, because there's a guaranteed ID there. Oh, why is this wrong? Yeah, this is interesting, because, wait a minute, how did that update thing work? Oh, so we are passing ID, sorry. There we go. And then we're gonna delete. Oh, I forgot delete. So we have set, get, update, set. Yeah, I guess it's delete. And then we talked about doing a transaction when we pass a callback instead. Oh, we're getting close. We're getting close. So what we're gonna do here, we're gonna say that if type of partial user equals function, we're gonna return this instead. Users collection, and that would be partial user. But we need that. Oh, tag nugget. Where's the transaction? Transact doc. Oh, yeah. And this will be user DTO, user DTO. Okay, so now we had like a very specific one for users, right? But we wanted to have the same thing for many collections. So let's create a function. And this is kind of my point. It's like the simple fact of just having a function. Like a function is so much more powerful than what we think about normally. Because we think about a function as like taking some params and executing something and then stopping. But a function is so much more, especially in JavaScript. And I think that that's something that passes us by very often. Like we've seen all the patterns we've done now with having like these constructors. Changing the history of state management. Well, but yeah, let's do the refactor here first. So I'm going to create a function that's called create a collection interface or something, and it's gonna take a generic of it's gonna take a generic, and that's gonna be like user DTO or whatever DTO. So, and then we're gonna take users here. We're gonna take all of this stuff, and we're gonna do this. And I think we can say extends object. And we are going to, yeah, sorry. And then we're going to pass in the collection. We need a collection as well. So this would be, how does this work? So this is a collection reference. Oh, it did it. What just happened? Where did my whole function go? Oh, did it actually... Wait, was this the AI? Or was it me? Maybe it was me. Cool. So now we have T. So we should be able to just say collection, T. And this will be, oh, extend, sorry, ID string. T. But let's rename this to rename doc. Oh, not doc. Data. And this will be T. This will be rename partial data. I'm gonna see what this is. We have to make sure we don't. This is T collection, T collection, T collection. Let's say users collection, collection. Do I have more users collection? No, we're done. What the hell does that mean? Oh yeah. Generics. Let's see. So users is going to be a create collection interface. And the cool thing is we can just say users collection, because now it infers the actual type. So this should be, you see this? It's filling out user DTO because it's inferring the type from the collection. That's beautiful. Oh, and it's all going green. Look at that. Are you impressed, Adam? Are you impressed? So we can say groceries, create collection interface, groceries collection, dinners, create collection interface, dinners. And then we have more to-dos collection. And we have weeks collection. And then we have this get week to-dos collection where I'm not sure what we're gonna do. Yeah, exactly. And the challenge now is that we have some collections that are based on a week. So we need some function here that dynamically generates a collection. And we're gonna call that. Because you can't use like create something like create week to do's. API, whatever, I don't know. Create week to do's. I'm just gonna call it interface or API. Yeah, whatever. And the point here is that, yeah, it understood it. So what happens here is that like inside the app, we're gonna like actually, based on the different weeks, we're gonna create these week to do's APIs. Maybe we can call this create collection API. Yeah, I think that's fine. And then Firebase or persistence API, I should say. Yeah, whatever. Create Firebase persistence like this. And then we don't have all of this. And then here we're gonna say, didn't I have create Firebase authentication? Oh, cool. And this is not like persistence. This is more like create persistence. Create family persistence. Oh, sorry, no, persistence. Sorry, we're gonna create the family persistence inside the thing. So let's call this context now. And then we're gonna go to session. And now we don't need all of this stuff. So we're gonna say authentication. And oh, fuck. One thing I forgot. There are two. Let's see. Dagnagit. Okay, sorry. So we're gonna return an actual object here because the actual users and families collection are actually something you can call regardless. Families, create collection API, families collection. And then we can also put create server timestamp, these two things here. And then we have create family API, which takes a family ID and it will return all of this stuff. It is a complex app, right? Because you have at the top level, you have users and families and authentication. And then you have different collections bound to the family. And then you have certain collections bound to the previous, current, and next week. Like it's complex. Anyways, this is looking fine. And then we can go back to family Scrum. Let's rename this to context. And then we pass in context. That's fine. Yeah, so I guess the biggest, session. Yeah, sorry, session. So we have authentication and persistence. So we don't have these things anymore. What we have, cached authentication, that's fine. What we have is authentication. Yeah, we could rename this unchanged. Cool. And then we're gonna say authentication sign in. And then we're going to say await. Now we're going to see how Firebase just disappears from our code. So we're going to say persistence users get. Look at that. Beautiful. Persistence families get. Wow. Awesome. And again, like the whole point here is like, what if I wanted to write tests and mock something? Imagine how difficult it would be to mock the previous Firebase API that we exposed. Or if I wanted to replace Firebase with something else. Like I would have to change everything in my app, but now I can just completely remove Firebase and implement something else. But that would never happen, right? That's the thing about like interfaces. It's like, it feels a little bit theoretical at times. But so I think a better argument is like, it's not about the flexibility to replace an implementation, putting it behind an interface. It's like running your app in different environments, which is really true for like web applications, because they can run natively. You have the test environment, they can run on the server. So that's a much better argument for doing something like this. And imagine being like yeah, you could even say like, yeah, I don't know. No, that wasn't a good point. Anyways, so let's clean this one up as well, and then I have to stop the. Yeah, I agree. I don't have any tests in this app, and yeah, I'm very much in the camp of having end-to-end tests in like what I subscribe to, which I tried to push through at Code Sandbox that we just didn't have time to do, is that you have Code Sandbox.io, but then you have next.codesandbox.io, and this is where you put your champions, like your user champions. So they will get all the features immediately, but there is some risk of bugs, right? But they'll have, and they get like a reduction in subscription price. They'll have more saying in the features added. Like you just have like your most passionate users on the next.codesandbox.io. And whenever you build something new, you just push it. You don't think about it. Every time main is merged, immediately goes to next. And then additionally on next, you automate the critical paths. So you have like an end-to-end test that actually runs on next in a production environment, just signs up a user, does the things that a user needs to be able to do to have a good experience. So that's just constantly running every time you merge the main. And that's it. No unit tests, no integration tests, nothing. And I think that's a much, much more healthy approach to doing product development, because there's so much synergy there. It's like you're bringing the passionate users closer to you. They're getting more feedback. They're like you're picking up edge cases based on actual usage, not because of code execution, but actual usage of the product. Yeah, I could write an article about that. Okay, so we don't need these. Yeah, so now we're here. I'm think maybe, I'm not sure. Well, I guess we want to do. Yeah, I think this is where we want to create the family persistence. So that would be, rename this to context dot persistent create family API. It's kind of weird calling it API, but yeah, whatever. So here we have family persistence. We don't need any of these collections. Yeah, and then we have family persistence. And now we're doing groceries on, oh, subscribe all. Don't use that one. Look at this. Family persistent dinners, subscribe all. And this is family persistent to do, subscribe all. Nice. And then we have week to do's. Okay, so here we can go and grab, let's change this to family persistence, create week to do's API by passing in the week ID. And then we're gonna rename this to week to do's API. With that week to do's API, we're gonna subscribe to a specific week. Subscribe to that specific week. Oh, what happened? Week to do. Did I do something wrong? Week to do's API, week to do DTO. Week data? What's week data? Oh. Oh, week data.week. Yeah, sorry. Week is week DTO. Week to do DTO. Oh, sorry. I think this is week to do's DTO. I was gonna. Oh, sorry. Sorry. Family persistence. Do we need week to do's API? On dispose on weeks. Yeah, sorry. I don't think we need this. So this is family persistence dot weeks subscribe. We're subscribing to the week, right? And then we have the week to do's, which is based on the actual. How is this? Let's see. Week to do's API is family persistent. Yeah. So week to do's API subscribe. Oh, subscribe all, I mean. There we go. This is how it should look. Sorry. Yeah. This is it. Cool. So this takes all the subscriptions and the core data of the app. This is nice. Okay, so we're gonna stop here. Refactoring. Nice, this was fun. And it feels super nice. It feels like going back to the how I felt about Overmind when we built that and kind of saw all the types coming together and everything. But that mental model was, as I said many times, was based on having this static state tree. And it was like, even though it's fun to create like accessible primitives and concepts, it's even more fun to just use the language and just have these patterns that helps you know where to make changes and how to expose things and how to compose and nest and all of this. We even tackled things like the strong contract between components and dynamic state, which is very, very exciting. So I'm pumped. We're going to keep refactoring this app following the patterns that we documented in Bonsify, and just keep discussing and talking and seeing things coming together. And then this is going to be a reference project for Bonsify. Yeah, this is going to be great. I'm pumped. Thanks for following along, and have a great day or night.